Okay, so number 6 is also another example of mean value theorem and trying to understand what it says and how it's useful. So a company introduces a new product for which the number of units sold S is S of t equals 300 times 5 minus 10 over 3 plus t, where t is the number of time in months since the product was introduced. During what month does S prime of t equal the average value of S of t during the first year? Okay, so if I try to make a visual to this, again, I don't know what this looks like, and I'm going to try to avoid using my calculator as long as I can. But it says t is in months, so first year. So if I'm trying to give myself a visual here, I would map this out to 12. So the average value of S of t, that would be like what happens, like what was the average number of cells? And so you would take what you got the first month and the last month, and you divide it by 12 because there's 12 months. That's how you get the average. So it sounds like I need to know S of 0 and S of 12 at the start and at the end. And so okay, and since I've got a fraction here, I don't know, I'm going to use my calculator, I guess. But when t is 0, that would be the start. Oh, it comes out to 500. I just assumed that it didn't. Okay, so before we get going, time 0 before we start, it's got 500. Okay, by the 12th month, because it said the first year, so that would be when t is 12. So so it looks like I did use my calculator to speed that up, but since it comes out to a nice whole number, I guess we could have done it without a calculator. So it's 1,300. So if I'm calling this 500, this is about 1,000, that's about 1,300. Okay, so this is the start, this is the end. This trajectory kind of maps out what the average number of cells is. Okay, so think about this, the mean value theorem. When it says mean, the word mean is like the average mean. So I can find the average here. So the difference between this and this divided by the number of months. But again, that's really just like the slope formula. It's just like that. So if at the end I ended up with 1,300 cells and I started with 500 cells, it means I've increased by 800 cells. But it took me 12 months to do that. And so that would be 66 2/3. And that's positive. So each month, on average, I'm selling 66 2/3 more than I did the month before. So just looking from start of the year to the end of the year, just a big picture. Now, of course, when you sell stuff, like, there's some fluctuation. It doesn't happen perfectly like this. It's not going to be linear. Sometimes it's going to be, I don't know, you're going to sell a lot, and then you're going to sell not very much, and then you're going to sell a little bit more. But in the end, that was kind of the end point. So I have no idea what this function looks like without graphing it in my calculator. But we can assume that it's not going to be linear. Okay, but so let's say it looks don't know, something like this. What the mean value theorem says, and of course that makes it very important, is that if this is your average slope, if this is a function that is continuous on the closed interval, differentiable on the open interval, which is just a mathematical way of saying it's not jumping around, it's not unpredictable, whatever this slope is, it has to occur at least once. There has to be at least one time that it has the exact same slope. And it could actually be multiple times, depending on what the function actually looks like. But that's it. The overall slope has to occur at least once if that function is continuous on the closed interval and differentiable on the open interval. It's not randomly jumping around. So it wants to know, well, when is that happening then? So I know what the average is. This is 66 2/3. And so looking at this, visualizing it, this would be the slope of the tangent line. So I want to know, when is the slope of the tangent line the same thing? Okay, well, slope of the tangent line comes from first derivative. So I guess mean value theorem doesn't really require any calculus until you do this. But if I just, actually, let me go ahead and distribute first. So that's what the function looks like. So if I took the derivative of this, I get 0 minus the derivative of this. You could approach that a few different ways. I guess I'm going to do the quotient rule though, and do the derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over the denominator squared. So 0 minus, and then this would go to 0. This would be negative 3,000, but if I multiply this negative to that, that would be positive 3,000. 3 plus t squared. Okay, so derivative is telling me, it's like a formula that will tell me the instantaneous slope for any value of t that I want, for any month. But I want to know, when is this the same as this? So when is the first derivative equal to that big overall slope from the whole thing? And instead of saying 66 2/3, I'm just going to leave it an improper fraction, just because I think that's a little easier to solve. Now I'm able to solve for t. I can figure out the month, or months plural, that their slope, their current instantaneous rate of change is the same as the overall rate of change for the whole month, or the whole year. I would probably solve this by cross-multiplying it first. And if I'm trying to solve this for t, actually, I guess I would divide both sides by 800. So that gives me 45. And again, I'm just solving a quadratic. So you could do multiple things. You could FOIL this out if you wanted to. It's really up to you. But I chose to divide both sides by 800. Because then I can take the square root of both sides. Don't forget, when you take the square root of both sides, to do plus or minus. Square root of 45 is the same thing as the square root of 9 times the square root of 5. So this is like plus or minus 3 square root of 5. And if I'm solving for t, I need to subtract the 3 over. So maybe negative 3 plus 3 square root of 5, and negative 3 minus 3 square root of 5. Of course, unless, oh, well, this one would be negative, right? A negative minus something's going to be negative. So that's going to be less than 0. So we're only interested in the first year. So it's not that. I would say whatever negative 3 plus 3 square root of 5 is, it's about 3.708. So somewhere during the third month, almost in the fourth month, there's some instant where it's selling at the same rate that's equal to the average rate over the entire year. So with this one, it might make sense to, I've already spent quite a while on this question, so I'm not going to take more time here since not everybody needs to see this one. But it may make sense for you to graph this, change your window settings from 0 to 12, because I'm only guesstimating on this blue. Like, I don't know what it actually looked like. It's probably more like, I don't know, it's probably something more like, actually, I don't know. I have no idea what it looks like without graphing it. But then if you went to this x value, you would see that it has that as a slope. And if you just kind of drew a line on your calculator from the endpoints, and then you went to this x value and you drew the tangent line, they should have the same slope. So unlike some of our other questions, you know, some of our questions are you need to know one or two things and then you just need a step or two and you're done. This one is pretty taxing in the number of steps. But, I mean, slope formula is not really a big deal. Solving a quadratic is not really a big deal. Understanding why I couldn't take the negative shouldn't be much of a problem. Cross multiplying is not really a problem. But just understanding the big picture here. Why did I do this? Why did I do that? Why did I set it equal to the derivative? That's the part that's really the understanding of the mean value theorem. That's why you want to have it down very well so that you have an idea of how to approach these. Okay, so I'd like to move on. This is too long for one question, but any follow-up questions that you need to ask there?